Yep. Exactly. So I know there's probably a lot of terms in there that confuse people. Like I said, in general, bare metal versus VMs. They are different. Understand that they're different, and understand that that can affect the speed of your application. Most of you probably don't need killer performance. That's why I'm not going to go into the details too much. If you want to know about it, I'll debate with you about it all day. But in general, like I said, the only thing you need to know is that VMs exist, bare metal exists. When you click a button and you pick a hosting provider, sometimes you might need more performance. If you're trying to emulate like GPT-2 training, then you need to care, because then you're spending $50,000. And you better know the difference between bare metal and VMs can be a day or two of training easily. So again, knowing for certain scales does matter. Just remember that. So there are certain scales of machine learning. Most of you, if you just want to run VGG16, probably don't need to care about that. But as the models get bigger, these things will become more relevant over time. So generally, that complexity is where AWS makes its money. That's why these cloud vendors give away all these models, saying, run these big models that we built internally on our compute and pay us. Verify our experiments, run on our cloud. That's generally what they want you doing. That's literally their business model. So they make money on the complexity. That's why they publish all these free. That's why they publish all these free libraries. Amazon has MXNet, Google has TensorFlow. I sell on-prem. Every vendor that publishes a deep learning framework generally sells compute time somewhere. Compute time or complexity, one of the two. That's why we just give it away, because you can't use it without some sort of compute anyways. And setting it up can be annoyingly difficult. So I'm giving you like the bare bones. I just want to run something version, right? But as you scale, somebody makes money. So moving on, Docker, as I mentioned, so are people satisfied with containers, like what they are? They're a small wrapper. There's not too much to think about in this context, but basically they're lighter weight. They're not. So people who actually know this stuff are gonna facepalm at what I'm gonna say. But the simple abstraction is, think of them as lighter weight virtual machines. They're not actually that, but it's a good analogy though. They're lighter weight virtual machines. The abstraction for the end user is essentially the same, which is why Docker for Windows and Mac are built the way they are. For the end user, they're essentially the same thing. They're an individual machine that just runs, and then it's a self-contained operating system. That's all you need to know. And containers generally don't have a GUI. Generally, containers are just a shell. So when you're interfacing with containers, it's just like a remote VM on EC2. That's all it is. If you log in and you have command line and you have a computer with a terminal, right? And that terminal is something that's not your computer, or something that's not your host computer. So your host computer is your base laptop, right? And then the VM or the container is something that runs on the host machine using the hypervisor. The hypervisor on your host, and it's the one controlling all these virtual machines. And each of these are self-contained, isolated machines with their own, disk space and whatever else. For the purposes of this workshop, that's all you need to know. They're lighter weight virtual machines, and intuitively they're the same for the end user. Is anyone struggling with that concept? Again, we're here to be super beginner. So whatever you want to get into, I'm happy to. Are we keeping up so far? Okay. So for those of you who don't want to ask questions publicly, you can also ask me questions when I'm during the break as well. Okay, so Docker, again, started in 2012. Now has a container runtime called Moby. So if you're confused about that, it's because Docker originally was this big monolithic thing. Docker started splitting up all its components, and then certain components of it are reusable now. Docker itself is a distribution of something called the Open Container Interface. So that is when you do Docker push, Docker pull, Docker run, Docker exec, all those commands, that actually uses a protocol. So Docker actually, when you type the command, is actually a client connecting to a server on your local machine, a Docker daemon. So whenever you have to restart Docker, that's actually the server, and it communicates over TCP. So again, it's actually using its own protocol. When you do Docker pull, there's there's actually a protocol for like downloading the container, setting everything up, etc. Right, so that's a daemon on your machine. So I'll show that on Windows, for example. Let's see, I should put this here now. Hold on, let me pull this up. So if I go to like settings, here we go. So this is a running daemon, right? Like, so you have like all these things you can configure, like shared drives, network, right? And then here's the main thing, your daemon. So your daemon, you can start the daemon, right? And you can configure it, right? So it says Docker's running, right? For example. So so the reason I had you take Docker pull earlier is because sometimes you won't have this nice little like settings menu you can look at. But in general, Docker should be running, right? You can also run. I'm not going to cover Kubernetes. It's a big rabbit hole. If you want to know about Kubernetes, I can show you that. I can show you that too if you're more advanced. Just for running things in your local machine, just Docker is enough. Do not turn on Kubernetes. It's a big resource problem. just know that later we'll have to configure. We're actually going to have to configure some things. For example, the amount of RAM. So see, it's just like virtual machines. You configure the amount of RAM, disk, and everything that you're using. This is why you need to know your software engineering fundamentals, right? That's why half the workshop is just prerequisites on this, right? Because for a model, right? So for example, how do you code? So for example, if you have FP32 precision, right? Like so, most of you use FP32 by default. Sometimes you're using FP64 for more precision. FP64 data type is double the number that is actually double the amount of memory that FP32 is. That data type matters. Generally, depending on your data type of your weights, or even your input data, things are bigger, right? So sometimes you'll see int 8 on TensorFlow, or int, whatever, int, FP, it could be FP16. You hear about all these data types and all these buzzwords. It's actually to reduce the amount of memory that your model takes up, right? So generally, if your model is really big, you need to care about this now. If you want to affect compute time, you need to care about this now. Like the amount of CPUs and everything, that affects your performance, because otherwise, what happens? You run out of memory. So you don't know what, you never know why. It takes you a while, like your model just stalls, and then it's like, okay, what happened? It just timed out. When it times out, sometimes it's because it ran out of memory. This is especially true in garbage collected languages, like Python or Java. For example, a lot of people I think kind of know this. So why are all these things written actually in C++? Python is this great interface language. It's not the actual language you use. It's not an actual proper language for implementing math, distributed systems, and everything else. It's not a systems language. You write low-level code that touches hardware in C and C++ with a Python interface. That's generally how it works, right? So every time you hear about NumPy and NumPy calls out to some math code, NumPy is actually really slow, by the way. Be really careful. If you want to do math, use TensorFlow or PyTorch. Just use something a little bit faster. NumPy is just a very sane default interface that runs on most hardware. That's why people still use it today. The C runtime of Python or of NumPy is actually very slow. But they do that. They don't try to optimize it because all these competitive runtimes kind of exist now. So there's not much reason to. So for example, the Preferred Networks folks implemented the Python interface and they call it CuPy, C-U-P-Y, right? Like so that there's all sorts of different things you can think of, right? Like so the NumPy interface is just at this point it's a file format for ND arrays. So for example, underneath the covers we implemented our own NumPy as well, right? Like so NumPy is a great way of describing a big matrix, essentially. But in general, all these things are written in C. That's really all you need to know. Python's it's called an FFI, a foreign function interface. That's the wrapper from Python to C. It's very easy to use. If you've ever used Python, you can sometimes you can rely on it to generate C code for you. So you have to do this compilation step and everything. When you want to write faster code, sometimes even when you're a web developer, sometimes you're using Python to optimize certain parts of your code. So generally this is taken care of for you. You don't have to worry about it as a developer a lot of the time, especially for just experiments. But just know that these things exist and just understand the difference between an interface language and an actual like an actual systems language like C, C++, Rust, Go, Java. Like so, generally these languages are statically typed. They have like very fast just-in-time compilers and all sorts of like they have all sorts of things behind them to make them faster, right? But they're harder to use. This is why most people just use Python and then they call out to something faster. So again, Python is a great interface language. When you see something purely written in Python, generally then generally it depends on the Python runtime. So for example, 99% of the time we're thinking of CPython, but there's also Jython, IronPython. There's actually different Python distributions. So IronPython calls out to C#, Jython calls out to Java, and then there's also PyPy as well. So there's actually different Python runtimes. Happy to talk about those later. Just understand that these exist. 99% of the time, it's CPython. So it's a fancy interface language calling out to C code. This is so all these libraries like PyTorch and everything else are just C. They're C and C++ at their core. So for example, PyTorch is actually just they took the C code from LuaTorch, copied and pasted it, and then added a Python wrapper. That's PyTorch. That's why they were able to create the framework so quickly. They copied and pasted their own C code base and then readapted it. So they just took what they already had and then just repurposed it. That's why PyTorch came out so fast. Like you didn't hear about it and all of a sudden it's this big thing. It's because they moved their Lua community over to Python. Right? But all they did was they copied and pasted the C++ core to and added a Python wrapper. That's actually what they did. And then it's the same committers working on that same code base.
How about the performance? Is it different from the original C++?
Not enough now. It's been updated quite a bit, but yeah, it started as like the original C core for the Lua version of Torch, which was created in NEC like 2004 or something, and then all those people moved to Facebook, and then that's kind of what. Not kidding. They actually all moved to Facebook.
Yeah, that's true. I moved to Facebook.
Yep. Oh, cool. Okay, there you go. See, so yeah, so a lot of those people, they all end up. A lot of them ended up at NYU and what have you. Right? Like so that's why Facebook has its own framework. Facebook, I think, is one of the only people not trying to sell you something. They just like they just like hiring people. That's why they have PyTorch.
Well, because on Facebook you are the product.
Yep, you are the product, exactly.
They're selling you.
Yep, they're selling you, exactly. So Microsoft, actually Microsoft, if you've heard CMTK, Microsoft doesn't use CMTK. They use PyTorch. Internally, most of the research labs actually use PyTorch now. And so there's a big push for something that's not TensorFlow. So Facebook, Microsoft, and Salesforce all commit heavily to PyTorch. So the Einstein guys also heavily use PyTorch as well. So that's why there's kind of this competition. There's kind of the split competition for research now. So actually the DeepMind guys used to use Torch. Actually, all their first code was actually written in Lua. All the so pre-AlphaGo. A lot of the Atari stuff, that was all Lua. All right. So Docker, OCI, Kubernetes, again, rabbit hole. Generally, you're not going to get this far. If you're going to use Kubernetes, probably use something like Google Kubernetes Engine or AKS, Amazon Kubernetes Service. There's a lot of different implementations of this now. So just understand you're not going to get this far. Just understand this exists. So, okay, so before we continue, so Suzanne?
Yeah.
Is he okay? Do you want a computer or something? Okay. We'll move on soon. There's a lot of prerequisites people don't know. If people are bored, feel free to go take a break. You don't have to stay. This is going to be interactive later on. Just if you and actually before I continue, do folks just want to take a break for like 5-10 minutes? Would that help? Okay. Yeah, let's take a 5-10 minute break and let's get people kind of. I know there's a lot of concept. There's probably a lot of concept overload here, but these are all. Yeah, go ahead.
Let's take a 5-minute break. If you guys want to have some snacks and some drinks too, and then
Yeah.
we'll continue.
Yeah. Yeah, that's cool. Yeah.
It's like, I'm a sometimes we were raising an inspector, which was sort of like options of
Monitoring, I'm going to set them back.
Do you think that